Hello, this is Mr. McGovern, and this is the third video in the AC electricity series where we are looking at transformers, how they work, and a formula followed by a bit of an example. So transformers are effectively taking what we've learned from inductors in earlier videos and applying them to an applied context. So what we have here is we have two circuits. And on the left circuit we'll call the primary coil, and we've got an AC voltage source for that. And what it's done is we've got a coil here, and that AC voltage makes a magnetic field. This iron core guides the field around. Right? Now, because this is AC, the field that it makes is changing. And we know that in the other coil, a changing flux generates a voltage. So this is how we get electricity coming out into the secondary coil, secondary circuit. Now, there's a number of uses for transformers in modern society. They're used in audio systems and lighting. The big reason we love transformers is that they are used to step up voltage and step down voltage. So here's some transformers you might have seen in real life. This is one on a street here, probably a step down transformer ready for getting the voltages ready for houses. And these are step down transformers as well. So they take your 240 volt wall outlet and bring it down to 5 volts ready for your phone. So stepping up and stepping down the voltage happens when you have a different number of coils or windings in the primary side to the secondary side. Okay, and there's so in this case we can have stepping up goes from a low number of coils to a high number of coils, and stepping down is if we went from a high number of coils down to a low number of coils. So the ratio between the voltages is equal to the ratio between the number of turns and the number of windings. So in this case, let's say there's 4 on the side, and I think there's not quite 8, but let's pretend there was 8. A ratio of 4 to 8 is 1 to 2, and that means in this case the voltage will be stepped up twice as much. So you can write that as a formula. The ratio of the number in the primary, so the number of turns in the primary side is MP, and then NS is obviously the number of turns in the secondary side, and that's equal to the ratio of the voltages. Okay, so the number of turns, that ratio is equal to the voltage ratio. Now, you can't just think, oh, hang on a second, if I can just step up the voltage, man, I'm just getting free energy out. You know, if I increase the voltage twice as much, isn't that great for just having an iron core here? The power on the input side is equal to the power on the secondary side. And we know power equals voltage times current. So if you're increasing the voltage, current has to go down. Okay, because you can't just create energy out of nowhere. So here's an example from an exam. I think this is from 2023, and this is just a little demonstration transformer. On one side, there's 12,000 turns. It's a coil with 12,000 loops. On the other side, it looks like it's 600. So she connects an AC voltmeter, calculate the RMS voltage she'd measure from the 600 turn. So we're going from high number of turns to low number of turns. So this is going to be stepping down. Make sure we have that, and we're looking for the ratio between turns, and that'll give us the ratio between the voltages. So 12,000 is their input side, 6,000 turns on their output side, and that equals the same ratio of the voltages. So let's just work out 12,000 over 600 is 20. So that means we're going to be stepping down 20 times. So the secondary voltage is going to be 20 times smaller. Rearrange that formula and you get 12 volts as your output. So transformers, we create them by having an iron core, and on one side you have the primary coil, on the other side you have the secondary coil. If you have different numbers of turns between the primary and the secondary, you can get stepping up and stepping down, and that's what we're looking at this year. How much the voltage gets stepped up or stepped down is given by the ratio of the number of turns. The number of turns ratio is the same as the ratio that the voltages either stepped up or stepped down. And finally, the power input and the power output are the same. You can't have that increasing, especially, even in a perfect inductor. You're not going to have any losses, but you're certainly not going to have it increasing, because if it was to increase, it would be creating energy, and that would be violating the law of conservation of energy. So because the powers are the same, if the voltage goes up, the current must go down.